Why and when do we use rapid prototyping? Prototypes are important in any multimedia project. They help the whole team see what the end product will look like and how it will function. And being able to see that end product helps them to give better feedback. The whole team discussions are more rich and the feedback can be more detailed. Now, prototypes are even more important when you're working with highly complex projects, with simulations and things like that. Any project where you have a lot of visual and interactive elements that are really critical to the project, you want to use a rapid prototyping approach. Designers who are unfamiliar with the subject matter have an even greater need of using the rapid prototyping approach because it allows you to work with the subject matter expert a little bit more closely and get their feedback at every step along the way. Now, the subject matter expert often has tacit knowledge. That's knowledge that's just part of their expertise, and they may not know how to convey it. So using a prototype, you can get at that tacit knowledge a little bit easier, and you can help them to express and find a way to describe what they're trying to teach. Just for example, one of the projects that we've done here at the college is a geology mineral lab. Now, let me preface this description by saying that this example is of really a simulation. It's not a simple presentation that you would have to do for ELN 202. It's a little more complex, so don't worry about the complexity of it as far as a project you have to create. But it is something that will help to demonstrate the importance of rapid prototyping in projects like this. Now, our existing lab for geology was what we'd call maybe a box of rocks that you would send to the students in the mail, and they would have the opportunity to manipulate the rocks, look at them, and do some tests on them at home, and then record their results. They would be looking for hardness with scratch tests and things like that, looking at luster, how the light bounces off of it, cleavage, or how it breaks, magnetism. I mean, there are a lot of things that they were looking at to identify samples that were sent to them in the mail. Now, what we needed to do was turn this in-person, or rather not in-person lab, but a physical lab into a virtual lab. So we took some time to meet with a subject matter expert, and we had her give us a demonstration, acting as if she were a student, putting all the rocks on a table and doing all of the tests herself. If you're training for a hands-on type of an activity, this is really important. You need to observe what the actual procedure is before you can start to design your program. So don't just trust the subject matter expert to give you or to know all of the steps and then to list them properly for you. Watch them, observe them, record, take notes, and then you'll have a better chance of really getting it right. Now, in this case, the geologist came in to meet with us, and she brought in her box of rocks, and she wanted to show us the whole thing. We had to ask her, what happens next? You know, what happens first, what happens second, what happens next? What if? We had to ask a lot of questions. Now, we video recorded that interaction with the faculty member so that we could get a better idea later on in our analysis of how the project, the end simulation, should work. Now, the results of this team meeting with the video was that it was very apparent that we needed to use rapid prototyping. It's a complex project. It's very visual and actually tactile in nature, and we had to try to make up for the tactile part missing in the virtual laboratory. It's also highly interactive. It was going to require some new techniques for multimedia. And due to all of those requirements, we decided we needed to follow more of a rapid prototyping methodology in our development.
So what we did first with the geology lab is we met with the subject matter expert. And for me, this was a chance to see how the lab should be done as it would be done by a person. As a media designer, I was able to sit and watch and see the way that things were done. The subject matter expert, the geologist, she explained the lab and the tests that were needed. She showed us the tests, like the acid test and the various scratch tests, the magnetism test. And students were going to be asked to identify physical characteristics that would only be discernible by visually inspecting the rocks. So it became apparent that we were going to have to do 360-degree video to show these things. As a multimedia designer, I walked away from this first meeting with a subject matter expert with kind of a mental image, an idea of the way that we wanted to do the interface. I was able to see that the rocks needed to be placed on the table, and then we were going to have to group these tests somewhere on the screen. And these ideas, this mental image, informed the initial layout.
What we did is we started, after this meeting, is we listed all of the media, all of the functionality that we wanted in the lab. We knew initially by looking at someone picking up a rock and turning it that we would need to have something like a 360-degree view of that rock for the students to be able to complete the lab. We knew that they would have to see close up what would happen if you put a dropper full of acid on the rock, if it would bubble or not. We have to get in really close to that. So all of those things that we learned from that initial meeting, from the video that we took of watching the geologist do the experiment herself, led us to the methodology we would use, and then led us into the kinds of problems that we would need to solve as we were going. We needed to explore and prototype all of the media elements. As I said, we needed to do a 360-degree view of each rock. We needed to have close-ups. We needed to be able to see every angle that someone would see if they were holding the rock in their hands. We took that box of rocks. That box of rocks had specimens of all different sizes. You had a pebble, and you had a big chunk of travertine, and everything in between. Different shapes. Some of them are paper thin. Somehow we had to photograph and video those rocks on a green screen so we could cut out the background and make them rotate and be seamless. We needed really good lighting. How do you see the luster if you don't have the lighting just right so you can see where the reflections are coming from off of the rock? We needed to be able to key out the background and make it appear that you're holding this, but without a hand there, just like it's floating in space, so you could see all of the angles that you needed.
With the initial layout done, we were able to move on to how to create the media. So once we kind of understood how we were going to be doing the things that we were going to be doing, it was time to move on to create the physical media. We knew, again, that somehow we were going to have to rotate these rocks 360 degrees and shoot the video for that. We knew that we were going to be photographing some tests. Not every test was going to have to be video because you don't really want to photograph a scratch you don't really want to video a scratch in a rock. So as we worked through the rocks, we found that there were a lot of different challenges with these rocks, and the biggest challenge was in the size and the shape of each of these rocks. Some rocks were paper thin and very small, and then we had big 15-pound pieces of travertine. So we need to be creative in our media approach. There were many different ways to accomplish this. So what we did is we built a lot of different ways to rotate these different rocks. So what we did is we went out to the store. We bought toys. We bought Play-Doh, silly putty, paint, markers, sandpaper, tools, PVC pipe, Nerf balls. We bought all these things. And after about 2 weeks of learning and playing, we had built a way to rotate these rocks by placing the rock. If it was a thin rock, we placed it inside of a Nerf ball with a slit cut in it, and we put that on a CD spindle, and we put that on a Lazy Susan, and we spun it. Otherwise, we put it on a piece of we either stuck it directly onto a CD spindle or on a Lazy Susan. And we rotated the rocks. Once we knew how we were going to capture the media and which types of media we were going to use for each test, and we had a layout, that's when we built our first prototype. And so having a strong understanding of the functional specs from the beginning and communicating the needs of the activity with all the team members and the subject matter expert proved to be essential to creating the first prototype of this project.
So once we had a lot of these media elements, prototyped, we had various samples of each one of them, we needed to storyboard and then prototype the user interface. We used a table. We decided to use a table because that's what we thought students would do. That's what our instructor did, or the geologist did when she came in to demo for us. She'd dump all the rocks onto the table, organize them, and then go from there. So we decided to use a table as the background, or tabletop as the background. How do those rocks fall when you dump them on the table? How do you organize them? We actually went around to several people and gave them the box of rocks and said, if you are going to do experiments on these, what do you do with them? And we just watched and observed how they would take the rocks out, put them on the table, arrange them in different ways, and get ready to do the experiment. We then looked at the interface on screen. Where are the rocks going to go? Where are we going to put all of the tests that we do? Because we have to go in closer to examine each of these rocks under each of the tests, whether it be a scratch test or an acid test or any of the others we were doing. So we decided to put that dead center. In the middle of the screen is where we had the kind of the examination place. We put all of the tools off to the right so you could drag them onto the center stage and see larger images of every experiment you were running. Now, after we were done with this prototype and with our initial idea of what the program would do and how it would act, you can reflect a little bit. Where did this come from? It came from some extensive planning. It came from observations. It came from exploring ways to solve programming and media capture problems that are challenges that we knew we would have. And once we had the prototype, everyone could see where we were. Everyone could see how it would interact, where the rocks would land, what the tests would look like, how if you dragged one onto the center, you could blow up a video or a still image and see the test happening so you could record your results for this experiment. We got feedback from the designer, the graphic designer, the programmer, the people taking the photographs and the videos, and the subject matter expert coming together to give good feedback on where we were. That allowed us to make some meaningful revisions down the road. So a well-executed prototype can actually speed up the development process for your complex media. It gets you off on the right foot.